Today we're going to talk about the detection of oil spills that are coming from illegal discharge or accidents from ships passing through the Adriatic Sea. Oil spills have catastrophic consequences for the environment and economy. Rapid response to a spill can basically reduce the extent of the damage and reduce cost. Earth observation is ideal for this problem because we can do it at a distance and in darkness to catch people illegally dumping. Another benefit of Earth observation is that it allows us to figure out the path that the oil spill is travelling and the volumes so that we are better prepared for when we detect the oil spill. We can send out a plane with extra sensors on that can take additional photos, and then all of this information can be used to actually legally prosecute. It's difficult to detect oil in water because of the nature of the way oil changes. In time, the hydrocarbons within it change, it mixes with water. Oil can be quite different depending on what type of oil it is. It can have quite a complex composition, and that will have different spectral property signatures. Also the issue of lookalikes. Sometimes other things look like oil but they're not, like algae, a shadow. We're after a spatial resolution that's going to pick up a ship. A ship's about 300 meters, and then it's got to pick up the oil coming out of that. Because we want to have a quick response, the quicker the better, we will need a temporal resolution that is basically revisits as frequent as. If you look at the image, you'll see that's the number of oil spills from one summer. So it's quite a big problem. So there's been a lot of research done on it. And in the graph you can see the volume of articles. Research is looking at trying to differentiate the lookalikes from oil spills and different classification techniques. The best way to detect oil spills with remote sensing data is to use synthetic aperture radar SAR Sentinel-1 data. Now the beauty of this is that it's working with microwave frequency. When the oil is on the water, it's not as rough, and that's what the radar is picking up. What's great about this is that it can be done in any weather, whether there's clouds, and it can be done in the middle of the night. It's really important that we know the wind speed and the wave height as well, because those two things impact the surface of the ocean, of the sea. So if the wind was low, it might look like there's more oil there because there's not going to be enough of that radar backscatter. And also they impact if the waves are high, at a big height, it breaks up the oil quickly. With image classification, basically it comprises segmentation, feature extraction and classification all together. And there's been quite a few different methods that have been tried, and we've broken it down to 4 here. Machine learning, most popular support vector machines, deep learning, segmentation and statistical methods. That I'm going to choose to classify the data here is support vector machines. Basically because it doesn't need as much training data as some other methods, but there's still limitations, and the limitation is that there's too many lookalikes being classed as oil spills, and also the time. Support vector machines will be more suitable for an oil spill accident. We get the data and then we'll pre-process it. So the data is a bit noisy and there's a speckle filter, and then we will need to prepare the training and validation data. So we'll isolate dark areas and do some feature selection. And next we're going to build the model. That's where we'll use the classic. So we want to figure out how good the model is by looking at how accurate it is, how it performs, and we'll do this with some cross-validation, and we'll also produce these measures to tell they have validated the model and it's come out really well. And I've come up with a good combination of classification, segmentation and feature extraction. Then I'd want to publish it and maybe putting it into a journal or presenting that at a conference.